Welcome to today's lesson. Today we are going to look at the determinant and the inverse of a 2 by 2 matrix. Now, what is a 2 by 2 matrix? This is a matrix that has got 2 rows and 2 columns. For example, like the matrix A that we've been given in a slide, where we have got A, B, C, and D. So if you look at those letters that are inside that matrix, these letters are being described as elements. And if you observe very well, there are 2 letters that are in yellow, and there are also 2 letters that are in red. Now, those letters that are in red are being described as the minor diagonal. These in red, we describe them as the minor diagonal. Then these ones that are in yellow, they are being described as the major diagonal. Okay, so we are told that when you are finding the determinant of a matrix, that determinant can be calculated by multiplying the elements in the major diagonal minus the elements in the minor diagonal. So therefore, we're being told there that the determinant of a matrix A is equal to the product of a major diagonal minus the product of a minor diagonal. Now take note, a product is an answer that you get after what? Multiplying. So we can summarize by saying that the determinant of A is equal to AD minus BC. So we can look at an example so that we can see how we can be able to compute or to calculate the determinant of matrix Q. So we are told there that given that matrix Q is equal to 3, -2, and -5 and 4. Now find the determinant of matrix what? Matrix Q. So if you look at this matrix very well, we are able to see that in the major diagonals, the elements that we have, that is 3 and what? And 4. Then in the minor diagonal, the elements that we have, it is -5 and -2. So how do you find a determinant if I've got a question like this one? So we shall say that determinant of matrix what? Matrix Q is equal to the elements in the major diagonal minus the elements in the minor diagonal. So determinant of Q will be equal to 12 minus what? Minus 10. Because if you multiply 3 by 4, it will give us 12. Then you multiply -2 multiplied by -5, it's going to give us 10. So the difference between 12 and 10 is the determinant of matrix Q, which is equal to 2. Like that. Now, kindly take note that the determinant of a singular matrix is 0. Okay, so the key word to look at is singular. The moment they just mention in a question that this matrix is a singular matrix, just know that that matrix has a determinant of what? Of 0. So we can look at example number 2. Okay, example 2. Given that P is equal to 3, -1, -2, and a 0. and matrix Q is equals to 3, 4, negative 4, and the x. Then we are told to find the value of x if P and Q have equal determinants. Okay, equal determinants. So what are these people trying to say in this question? This question is trying to tell us that a determinant of matrix P is equal to the determinant of matrix what? Of matrix Q. Therefore, if you look at matrix P, you observe that the 3 and the 0 are in the major diagonal. The negative 1 and the negative 2 are in the minor diagonal. So we shall say that 3 multiplied by 0 minus negative 1 multiplied by negative 2, okay, equal to, if you look at matrix Q, you observe that the 3 and the x are in the major diagonal, minus the 4 and the negative 4 are in the minor diagonal. So when you multiply 3 by 0, we're going to get a 0, minus negative 1 multiplied by negative 2, we're going to have a 2, being equal to, then 3 multiplied by x. This will be equal to 3x, minus, then 4 multiplied by negative 4. This will give us negative what? Negative 16. Now hear me and hear me very well. 0 minus a 2. This one is going to give us negative 2. Then here there are two signs, meaning we are multiplying. Okay? A negative multiplied by negative is going to give us positive what? 16. So at this stage, what are we going to do? We are going to correct the what? The like terms. Okay, like that. So correcting the like term, that means this 16 will cross over to the other side. Now take note, whenever a number crosses an equal sign, the sign of operation changes. If it was a negative, it will become a positive. And if it was a positive, it becomes a what? A negative. So we're going to have negative 2 minus 16 being equal to 3x, like that. So what happens there? Negative 2 minus 16, this one will give us negative what? Negative 18 being equal to 3x. We're able to get negative 18 here because the signs are the same. If the signs are the same, what do? You put them together and maintain the sign. So at this stage, you are going to divide, okay, both sides by what? By 3. Okay, so you divide by 3 because we're interested in finding the what? In finding the x. So if you divide by 3 there, you're going to say, okay, 3 into 3, you remain with an x there. So this 3, it's 1. 3 into 18 is going to give us negative what? Negative 6. So x is equal to negative 6. And that becomes the answer to this question. Okay, we proceed with our lesson for today. And now we'll look at the inverse of a matrix. Now, what is this so-called the inverse of a matrix? Remember, we cannot find the inverse of a matrix if we haven't found the determinant. So the first step in finding the inverse of a matrix is for you to find the determinant of a matrix. Now, how do you find the determinant of a matrix? We're just from learning from our two examples that the determinant of a matrix can be calculated by us having the product of a major diagonal minus the product of the minor diagonal, which will be determinant of matrix A being equal to AD minus BC. Okay? Therefore, after you find the determinant, take note. The inverse of a matrix is equal to 1 over determinant. Now, these elements that are in the matrix, something happens. You discover that these elements that are in the major diagonal, they are going to exchange or interchange. The D will go where the A is, and the A will go where the D is. So these, they interchange. Then the elements that are in the minor diagonal, they change the sign. If the sign was a positive, it will become negative. And if the sign was a negative, it will become what? Positive. So as you can see now, between C and D, these ones have become negatives. The reason being is in the original matrix, they were positive elements. So we have now multiplied by 1 on the B and the C to see to it that you have got the negative what? Negative signs. Therefore, we can look at an example under inverse of a matrix. For example, we are told that given that matrix Q is equal to 3, -2, -5, and 4. Now find the inverse of matrix what? Matrix Q. Okay? So, how are we going to find the inverse of matrix Q? The first thing that we do is to find the determinant. So we shall say that determinant of matrix what? Q is equal to 3 multiplied by 4 minus -2 multiplied by negative what? -5. So determinant of Q will be equal to 12 minus what? 10. Okay? So determinant of Q is equal to what? To 2. So that is the determinant of this matrix. But the question says find the inverse. So what are we going to do? We shall say that inverse, okay, of matrix what? Of matrix Q, which can also be denoted as this, is equal to 1 over the determinant. Now listen, remember what we says? We says the element in the major diagonal, what do? They interchange. So meaning where there's 3, we're going to put a 4 there. And where there's a 4, we're going to put what? A 3. And these elements that are in the minor diagonal, they change the sign. Okay? So the -2 will be +2. And the -5 will be positive what? +5. Therefore, we shall say that 1 over 2, because our determinant is 2. Okay? What do we have in the inside the matrix? We have a matrix we describe as the adjoint. Okay? Where the major diagonals have interchanged, then the minor diagonals have changed the what? The signs. So that would be a 4, a 2, a 5, and a what? And a 3, like that. Okay? So therefore we shall say that the inverse of that matrix is equal to this 1 over 2 that we're seeing. It is multiplying all the elements that are inside this adjoint. So 1 over 2 multiplied by 4, our answer there is 2. Then 1 over 2 multiplied by 2, our answer will be what? 1. Then 1 over 2 multiplied by 5, our answer will be 5 over 2. Then 1 over 2 multiplied by 3, our answer will be 3 over what? Over 2. And that becomes our answer for example 3. We continue. and look at example 4. But before we can go to example 4, for those who are interested, or for those who are interested or needs more videos concerning different topics, they can be able to call us on the numbers that are showing on the screen. Therefore, we can go to example 4. So example 4 is our last example, and the question says, given that matrix A is equal to 4, -5, 1, and 2, and B is equals to 8, Y, 3, and 5, then number 1, find the value of Y for which the determinants of A and B are equal. Determinant of A and B are what? Are equal. So if you look at matrix A, you are able to see there that in the major diagonal we have got 2 and 4. In the minor diagonal we have got 1 and -5. If you look at B, in the major diagonal we have got 8 and 5. In the minor diagonal we have got 3 and what? And Y. So how are we going to solve this? We shall say that the determinant, okay, of matrix what? Matrix A is equal to determinant of matrix what? Matrix B. Therefore, elements in the major diagonal on matrix A, we've got 4 multiplied by what? 2, minus the minor diagonal, got -5 multiplied by 1, being equal to determinant of matrix B. Major diagonal, got 8 and what? And 5, minus Y multiplied by what? 3 in the minor diagonal. So if you look at that, 4 multiplied by 2, our answer is equal to what? To 8, minus -5 multiplied by 1, that is negative what? -5, being equal to 4 multiplied by 5, that's 40, minus Y multiplied by 3, that will be 3Y, like that. So negative multiplied by negative, we're going to have 8 plus what? Plus 5. So the addition of 8 plus 5, it's basically the determinant of matrix what? A, is equal to 40 minus what? 3Y. So 8 plus 5, our answer is 13. So that is the determinant of matrix C, A, and also that is the determinant of matrix what? Matrix B. Now, at this stage, what are we going to do? We are going to collect the what? The like terms. Correct the like what? Like terms. Okay? So meaning when this 3Y crosses the equal sign, it will be positive. Okay? And when this 13 crosses the equal sign, it's going to be what? To be negative. So therefore we shall say that 3Y is equals to 40 minus 13. We are going to have 20 what? 27. So what do we do at this stage? You divide both sides by what? By 3. Okay? So when you divide both sides by 3, 3 and 3, you remain with the Y. So 3 there, 1. Then 3 into the 27, we are going to have Y being equal to what? Being equal to 9. So we have solved the part 1. We'll now go to 2, where we are told, hence find the inverse of B. Now, when finding the inverse of B, since we have been told that these two have got equal determinant, so as you can see that the determinant of A was 13, so that means that even the determinant of B is what? Is 13. So in that case, we are going to find the inverse of b. So in finding the inverse of b, you're going to replace y with its numerical what? Numerical value. Okay, and that numerical value is what? Is 9. So we shall say that okay, matrix B is equal to 8 and 5 there, then here were the 3 and we have a 9, like that. Okay, so this is the matrix B. Now we are told that the inverse of matrix B is equal to 1 over determinant. Okay, so the elements in the major diagonal, which is the 5 and the 8, so the 5 will go where 8 is, and the 8 will go where 5 is in the original matrix. Okay, therefore the 3 and the 9, which are in the minor diagonal, they just change the sign. So this will be -3 and that would be negative what? -9. So therefore we shall say that the inverse of B is equal to 1 over 13, like this. Then we're going to have 5 there, -9, -3 and 8, like that. So this 1 over 13 is multiplying everything that is in this bracket. So 1 over 13 multiplied by 5, we're going to say 5 over what? Over 13. Then 1 over 13 multiplied by -9, that would be -9 over what? Over 13. Then 1 over 13 multiplied by -3, that would be -3 over what? Over 13. Okay, then 1 over 13 multiplied by 8, that would be 8 over what? Over 13, like that. So that is the inverse of matrix B. We have now come to the end